Traditionally, trigonometric functions are defined in terms of the sides of a right triangle. Now, this does have some limitations, so there's a more modern definition that we'll get to shortly. But the old school definitions are still a good place to build on. So first, trigonometric functions are always defined in terms of an angle. So starting from this angle here, there are three primary trigonometric functions. The sine of the angle, which we abbreviate sin of theta, is equal to the length of the opposite side, that's O, divided by the length of the hypotenuse, that's H. All right, now the cosine of the angle, abbreviated COS of theta, is the length of the adjacent side divided by the hypotenuse. And finally, the tangent of the angle equals tan of theta is equal to the length of the opposite side divided by the adjacent side. And that's it. Right? These are the three core functions that really pretty much all of the rest of trigonometry are going to be based on. Okay, so let's look at an example. Right? First, we need to pick an angle. Right? If we call this one theta, right, then let's see. The sine of theta is equal to the opposite side's length. That's 3, right? Here's the opposite side, divided by the hypotenuse, that's 5, or 0.6. All right, now the cosine of theta will be the length of the adjacent side, right? That's 4 divided by the hypotenuse, which is still 5, which is 0.8, right? And then finally, the tangent is the opposite side, that was the 3, divided by the adjacent side, that's the 4, or 0.75. Right? That's it. That's how we can actually get these functions if we have a triangle to look at. Now, to give you some practice, right? Suppose, let me clean up just a little bit here. Put my theta back. Didn't mean to delete that. There we go. Suppose we look at this from the perspective of the other angle, right? If we let this angle be phi, that's not an empty set. I know they just look a lot alike, right? That's the Greek letter phi. Try working out the three values for phi on your own, right? Then we'll go over them together. Okay, so let's see. For this angle, the opposite side is 4, so the sine is going to be 4/5, or 0.8. And now the adjacent side is the 3, so the cosine is 3/5, or 0.6. Finally, the tangent is the opposite side, that's 4, divided by the adjacent side, that's 3, so it's 1.33, and that's a repeating decimal there. Okay. Now, the sine, cosine, and tangent are the core trigonometric functions, but there are 3 more, each one based on one of the original primary ones. And you can see how they're all defined here, right? They're all defined just by taking one of those primary functions and flipping it over, right? So this one, the secant of theta is 1 over the cosine. The cosecant is 1 over the sine. And finally, the cotangent is 1 over the tangent. All right, so this is our right triangle again. Very similar we were working on before. And I listed out the sine, cosine, and tangents, the one that we found already. So now what I want to do is I want to fill in the 3 remaining ones. So the secant is 1 over the cosine. So that's going to be 5/4. And the cosecant is going to be 1 over the sine. That's 5/3. And finally, the cotangent is 1 over the tangent, which is 4/3. All right, so looking ahead, we're going to be using these 3 functions continuously for the rest of the class. So you should invest some time getting comfortable with them, right? And in the next lecture, we're going to get some more practice by looking at some specific angles where we can determine the exact values of each of their corresponding trigonometric functions.